Imagine a scene straight out of a Hollywood blockbuster. An astronaut, adrift in the dark void of space, struggles to get back to their ship before their oxygen runs out. Suddenly, an accident occurs. Their helmet is damaged, exposing them to the deadly vacuum of space. But what really happens in that moment? Is reality as dramatic as the movies suggest? This is a scenario that captures the imagination of many, fueled by both scientific curiosity and speculative fiction. However, amidst the echoes of pop culture and the accounts of real science, there lies a chasm of misunderstandings and myths. Today, we're diving deep into the question of space survival, debunking popular myths and replacing them with solid facts and fascinating science. Our goal is not only to correct misconceptions but also to shed light on the incredible science behind human survival in the vacuum of space. In doing so, we'll reveal not only the dangers but also the wonders and technological achievements that make space exploration possible. We're here to separate fiction from reality, myths from truths, and delve into the true nature of space, an environment both beautiful and brutal. Myth explanation. One of the most persistent and visually dramatic myths is the idea that when exposed to the vacuum of space without protection, the human body immediately explodes due to the lack of external pressure. This concept has been a cornerstone in many works of science fiction, leading to the belief that space is an instant and violent death sentence for anyone unfortunate enough to face it without proper protection. Scientific reality, the truth, however, is less cinematic but no less fascinating. According to research and data collected by space agencies around the world, the human body is incredibly resilient. While exposure to the vacuum of space is extremely dangerous, it does not result in instant explosion. In reality, the person would remain conscious for about 10 to 15 seconds, as the remaining oxygen in the blood would be sufficient to maintain brain function temporarily. The expansion of gases in the body could cause discomfort and swelling, but not to the point of explosion. Eventually, the lack of oxygen would lead to loss of consciousness, followed by hypoxia and hypercapnia, resulting in death if rapid intervention did not occur. The myth is based on a misunderstanding of the laws of physics and human biology, assuming that the human body would react to vacuum as a rigid structure, when in fact, our skin and tissues are strong enough to keep the internal organs protected from the pressure difference. While the long-term effects of exposure to vacuum are fatal without immediate intervention, the reality is that there is no dramatic bodily explosion. Explanation of the myth. Many people believe that once exposed to the vacuum of space, the human body would instantly freeze due to extremely low temperatures. This idea is often reinforced by scenes from movies and TV shows where characters are cast into space and quickly become floating ice statues. The logic behind this myth seems solid at first glance, considering that space is often described as a cold and desolate void. Scientific reality, however, the reality about temperature in space is more complicated than the myth suggests. Space itself has no temperature in the traditional sense, as temperature is a measure of thermal energy contained in matter, and space is an almost perfect vacuum, virtually devoid of matter. Therefore, a body in space doesn't lose heat instantly through conduction or convection, as would happen on Earth. Instead, heat can only be lost through radiation, a much slower process. In reality, an unprotected astronaut in space would initially experience a sensation of cold in the lungs and exposed skin, due to rapid evaporation of bodily fluids, but wouldn't freeze instantly. In fact, in areas directly exposed to sunlight, temperatures can rise dangerously, potentially causing overheating. The thermal dynamics of the body in space are thus influenced by direct exposure to the sun or shade, but the temperature adjustment process is gradual and complex, not instant freezing. Debunking the freezing process. The notion of instant freezing in space overlooks the basic principles of heat transfer and thermodynamics. The human body, due to its ability to radiate heat, would actually take hours to cool down to deep space temperatures, assuming there is no direct exposure to sunlight. This misconception is an excellent example of how fiction can influence our perception of science, emphasizing the importance of scientific education in understanding complex phenomena. Myth explanation. There's a common misconception that in an emergency situation, a person could breathe in space for a brief period, perhaps attempting to hold their breath to survive longer while seeking safety. This myth is fueled by depictions in the media where characters are seen doing just that, suggesting that space, although dangerous, offers a small window for heroic survival action. Scientific reality, in fact, attempting to hold one's breath in space would be fatal. The lack of atmospheric pressure in the vacuum of space would cause the expansion of gases within the lungs, resulting in severe injuries or lung rupture. Furthermore, without air pressure, gas exchange in the lungs, the process of oxygen entering the bloodstream and carbon dioxide being expelled would cease completely. Direct exposure to the vacuum would also lead to rapid loss of consciousness due to oxygen deprivation, making any attempt at breathing impossible. Moreover, the rapid decompression that occurs when exposing the body to vacuum can cause bodily fluids to boil due to the drastic reduction in pressure. This includes blood and other fluids, not just respiratory ones. Thus, the idea of holding one's breath or attempting to breathe in any way is impractical and highly dangerous. Debunking breathing capability. Survival in space without proper space gear is impossible due to many factors, with the inability to breathe being one of the most critical. This reality underscores the importance of life support systems in spacesuits and spacecraft, designed to replicate Earth's atmospheric conditions as closely as possible. Space exploration requires extensive preparation and protection, far from the simplicity suggested by the myths of breathing in space. Myth explanation. A concept often depicted in science fiction is that of booming explosions, screams, and other dramatic sounds occurring in space, along with swift, unimpeded movements. The idea that space operates similarly to Earth in terms of sound and movement contributes to exciting cinematic scenes, but significantly distorts the physical reality of space. Scientific reality. Space is an almost perfect vacuum, which means there is virtually no medium through which sound can propagate. On Earth, sound travels through air or other mediums like water and solids, but in space, the absence of air prevents sound waves from moving. Therefore, explosions in space would be silent to a human observer, and direct verbal communications would be impossible without the use of radios or other transmission devices. As for movement, the lack of atmosphere also means there is no air resistance, significantly altering the way objects and people move. Movements that would be swift and agile on Earth can become slow and awkward in space due to the absence of gravity and atmospheric resistance. This is particularly evident in videos of astronauts on the International Space Station, where every movement requires care to avoid unintended actions due to microgravity. Debunking movement and sound. Understanding these fundamental differences is crucial for appreciating the true conditions of space. The inauthentic representation of sound and movement in space by the media contributes to a distorted perception that can obscure the public's understanding of space exploration and the laws of physics. By educating about these realities, we can more fully appreciate the complexities and challenges of life and movement in space, as well as recognize the technological advancements that make space exploration possible. After debunking popular myths about survival in space, it's essential to understand how, in reality, astronauts are able to live and work in the inhospitable environment of space. Life support systems in spacesuits. The spacesuit is a marvel of technology, functioning as a personal mini-space station. It's designed to provide everything an astronaut needs to survive: oxygen to breathe, regulation of body temperature to deal with extreme fluctuations of heat and cold in space, protection against cosmic radiation, and mobility to perform essential tasks. Every aspect of the suit is meticulously designed to ensure survival and functionality in the vacuum of space. Life support systems on the ISS. International Space Station. The ISS is an orbiting laboratory equipped with advanced life support systems. It recycles air and water, a critical necessity for long stays in space. The station also maintains an atmospheric pressure similar to that of Earth, allowing astronauts to work comfortably without spacesuits. Additionally, the ISS is equipped with systems to remove carbon dioxide from the air and control humidity levels, ensuring a habitable and safe environment for its international crew. Astronaut training. Preparation for life in space begins on Earth, with extensive training that simulates space conditions. Astronauts undergo training in microgravity environments, such as parabolic flights, and practice extravehicular activities in large pools that mimic weightlessness. This training not only familiarizes them with the equipment they will use in space, but also prepares them psychologically and physically for the challenges of life beyond Earth. Technology and innovation. Behind every life support system, there are years of research, development, and innovation. Current space missions benefit from decades of experience and technological advances, allowing humans to live and work in space more safely and efficiently than ever before. Space exploration is a testament to human curiosity and the relentless pursuit of knowledge, driven by technology and the desire to explore the unknown.